Hey everybody, in today's lesson we're going to be looking at the tangent ratio. So in the last couple of lessons we've looked at sine ratio, which was the SO, and then we had the cosine, which was the ca, and now we're looking at the tangent ratio. So we're going to be using the TOA, which is going to help us remember what goes with what. So when we're looking at the tangent ratio, we're going to be looking at tangent theta equals opposite over adjacent. And abbreviated would look like tan theta equals O over A. And that's where that TOA comes from. We have tan, so the T, and then the O for the opposite, and A for the adjacent. So that'll help you remember how to solve using the tan ratio. Now, this diagram is nicely done for us this time. So we can tell that we have an angle right here. So we have angle A. And the opposite is going to be right across, and the adjacent is going to be your other leg that is touching it right here. And right here, C would be your hypotenuse, but we're not going to use that when we're calculating using the tangent ratio. So let's look at this example here where we have x, y, z, and we have 4, 5, and 3 as our lengths for this triangle. Remember, we can only use this on a right triangle. So we have tan x that we want to solve for. So we're looking at this angle at the top here. We want to use opposite and adjacent. So opposite is going to be right across, and it's going to be 3. Adjacent is going to be touching it, and it's not going to be your longest side. Remember, your hypotenuse is right across from your 90 degrees, so our other leg there would be 4. Now, if we were solving for tan z, we have our bottom here, and we want our opposite, which is right across, and then we have our adjacent, which would be right below. So we have 4 over 3. Remember, make sure you're not confusing it and using the hypotenuse. You always want your opposite over your adjacent. For example 1 here is going to be similar to how we did this for sine and cos. You want to use your calculator to determine the following tangent ratios. Round to 4 decimal places. So important that you're going to 4 decimal places when we're looking at these numbers. Now, if we put tan 15 into our calculator, what we should be getting is 0.2679. Now, important here that you have your calculator in degrees. If it's in the wrong mode, it won't give you the correct ratio. So you have to make sure that it says DEG on your calculator when we're solving for trig concepts. Now, if we're looking at B here, we have tan 30. Tan 30 is going to be equal to 0.5774. Tan 60 is going to be equal to 1.7321. And now, like the other ones, I'm going to leave this last one for you to calculate on your own so that you can confirm that you are putting it into your calculator correctly. So please make sure that you are doing this on your own to make sure that you understand how to properly type it into your calculator. Now, what trends do you notice about the values of the tangent ratio in the previous examples? Well, when we started with the lower angle, so 15, and went up to 30, you can tell that the numbers are increasing. So your ratio is increasing because we went from 0.2 up to 0.5, and then after that we went to 1.7. So it's increasing as the angles increase. The next part says, what angle would give you a tangent ratio of 1? Well, if we look at our angles that we did right here, tan 30 gave us 0.57 and tan 60 gave us 1.7. So it's going to fall in between there. And to get a ratio of 1, it's going to be tan 45 is equal to 1. So when we have a 45-degree angle, it's going to give us a ratio of 1. Now in example 2 here, it says to calculate the value of tan A to 2 decimal places. So important, we're going to 2 decimal places and we're using the angle A here. So going by that setup of the tan ratio or tangent ratio, we have tan theta equals opposite over adjacent. Well, if we're doing angle A, tan theta is going to be equal to 4.3 because this is opposite. And then we have our 6.9 on the bottom because that's going to be our adjacent angle. Now, if we do 4.3 divided by 6.9, we're going to get tan A equals 0.62. Now remember, we're going to 2 decimal places here. If we were asked to turn this into the angle, then we would have our angle equal to, so angle A would be equal to 32 degrees. Now remember, you have to do tan and your -1 of 0.62, and that'll give us angle A equaling 32 degrees. Now remember that you're rounding to a whole number. So it actually comes out as 31.79, and we're rounding it up to 32 degrees. Now for B here, we have angle A at the bottom over here on the right. We want to use our opposite and adjacent when we're calculating for tan. So we have tan theta equals opposite over adjacent. Our opposite of A would be 5.2. So tan A is equal to 5.2 over, we want our adjacent, which is going to be our other leg, which is right here. Remember, we're not using our hypotenuse, which is always our longest side, and it's across from our 90 degrees there. So we want to use 8.1 on the bottom. So we do 5.2 divided by 8.1, and we'll get tan A equal to 0.64. Now, if we were asked to turn this into an angle, what we would do again is we do tan -1, and to get that on your calculator, you're doing second function tan, and then 0.64, which will give us angle A equal to 33 degrees. Now it comes out to 32.6, but we are rounding it up to 33 degrees here. Now we can look at this part here, and it just has something where it mentions that the tangent ratio can be used to help you find the missing parts of a right triangle. So this time we're going to be finding the missing lengths on this right triangle. So we're given the angle that we need here. So to calculate for x, we have our angle down here. We're going to have our opposite, which is going to be x, and we're going to have our adjacent, which is going to be 6.5. So if we're looking for tan theta equals opposite over adjacent, we now have tan of 38 equal to x over 6.5. Reminder that this would be over 1, and what we want to do is our cross multiplication. So we'd cross it over here, and what we end up with is x is equal to 6.5 tan 38. We do 6.5 multiplied by tan 38, and we're going to get x is equal to 5.1, and we want to double check. Our unit is centimeters, so we're going to have 5.1 centimeters as our final answer for what x would be. Looking over at this one here, we have our angle of 51 on this side, so on the left hand here. Our opposite is going to be 9.3, and our adjacent is going to be x. So using tan theta equals opposite over adjacent, we have a tan of 51 is equal to 9.3 over x. And reminder that this is all over 1, but when we have our variable on the bottom here, we can flip this over. So flip this over, and we're going to look at 1 tan 51 is equal to x over 9.3. Now this 9.3 will multiply up with that 1, so you're going to have 9.3 divided by tan 51 is equal to x. Now if we do 9.3 divided by tan 51, we're going to find out that x is equal to 7.5, and we look up again for a unit, and it's going to be meters. So we have 7.5 meters as our final answer for x here. Moving on to the next page, we have some real life examples here. So we have to figure out what exactly they're asking for. At the Gull Harbor Lighthouse is located on Manitoba's Lake Winnipeg. Assume the lighthouse is 14.6 meters tall and stands 7 meters above the surface of the lake. If the angle of depression to a boat on the Lake Winnipeg is measured at 27 degrees, approximately how far away from the base of the lighthouse is the boat? So they've drawn out the diagram here, and we have our measurement of our angle, which is 27 degrees here, which is also the same angle on the bottom here. So that's our 27 on the bottom there. And we're trying to figure out approximately how far away from the base of the lighthouse. So right here is our base of the lighthouse, and we're trying to figure out how far away it is from there. So what we need is we have our opposite and we have our adjacent. Well, we know the height of our lighthouse in the hill, so that'll give us our opposite, and we have to find out what our adjacent is. So our height for our lighthouse plus the hill would be 14.6 plus 7, which gives us 21.6 meters. So we're going to use that 21.6 meters, and we'll have tan theta equals opposite over adjacent. So tan, and we have an angle of 27, is equal to opposite is 21.6 over our x, which we're trying to find out. Now this will be just like that last problem we did, where we have everything over 1, and when our variable is unknown on the bottom, we can flip these over. So we want to flip these over, and what we'll get is 1 over tan 27 is equal to x over 21.6. Now this multiplies up, and you're going to have 21.6 divided by tan 27 is equal to x. Now to finish this off, we do 21.6 divided by tan 27, and we'd find out that our x is equal to 42.39, and our unit that we're working with is meters. So the boat is 42.39 meters away from the base of that lighthouse. Now for our next example, we have Una observed a boat from the top of a 70-meter cliff near Atlin, BC. She noted that the angle of depression to the boat was 25 degrees. How far is the boat from the base of the cliff? So we have another very similar type question where we have a 70-meter cliff. We have an angle of depression of 25 degrees. So we have our imaginary cliff right here. If we remember that your sight line is going to go straight out, so right out from the cliff, and we have a nice boat right here. So we have our boat right there. Our angle of depression to that boat is 25 degrees. So 25 degrees is right here. That's our angle of depression. With the cliff dropping straight down, what we're going to get at the top is a 90-degree angle. So if we have 90 degrees subtract 25, which is our angle of depression, we can find that that missing angle there is going to be 65 degrees. So this angle inside is going to be 65 degrees. Now we'd have our water going across here up to the boat, and we know that our cliff is 70 meters. What we're trying to find is how far is the boat from the base of the cliff. So we're trying to figure out this part right here. So let's call this x. Now, if we use our tan ratio, we have tan theta equals opposite over adjacent. So we're going to have tan of 65 is equal to our opposite from 65 is going to be our x over our adjacent is going to be 70. So we have all this over 1, and we're going to do our cross multiplication. So what we end up with is x is equal to 70 tan 65. And we can do 70 multiplied by tan 65, and we're going to find out that x is equal to 150.12 meters. So the distance from the base of the cliff is 50.12 meters. Now, that'll finish it up for our tangent ratio, and our next lesson we're going to be looking at is finding angles. So if you have any questions, please make sure you send me a message on Teams. Other than that, have a great day.